Okay, what we're going to look at in this section is just solving out rational equations. And there's a couple different ways that you can do that, and I'll show both several times as we go through this section. But one of the ways that you do this is by getting a common denominator on both sides of an equation and then solving backwards for your x. And so there's a couple different ways that we can do this, but let's go ahead and start. The common denominator on this first guy, if you look, the right-hand side needs an x plus 1. The left-hand side needs a 4x plus 5. And so when you multiply by these things, you could call even cross multiplication if you want. If there's an equal sign in there, and what that's going to give us on the right-hand side, it's going to give us 12x plus 15 equals, and then on the right-hand side, 9x plus 1. So this, or 9x plus 9. So this is how it's going to look when you cross multiply. Okay, and basically you're just filling in what you don't have. Okay, and then we take all our same steps that we've used 1,000 times before to solve this problem. So we're going to get all the x's together on one side. So we're going to subtract 9x. And when we subtract 9x, we have 3x plus 15 is equal to 9. And then divide both sides, or subtract 15 from both sides. Can't get my colors to work here. Minus 15. And divide both sides by 3. And so here's the first guy. Now, always double check to make sure that the answer you have is one that will work. So we're just going to double check this negative 2 real quick and make sure that we don't get a 0 in the denominator. And so negative 2 plus 1, that's going to give me a negative 1. I'm good. And then 4 times negative 2 plus 5, that works as well. So we're okay. So my final answer on this first guy is x equals negative 2. Sometimes, though, things get all jumbly, and they're not all perfectly set up by an equal sign. So we need to clear out the fraction. And I like to do this. I think it's a great way to make your problem a lot easier to solve. But your common denominator on this guy is 4x. Okay? And so what we're going to do is we're just going to multiply every piece of this equation by 4x. So we're going to take that 4x, and we're going to come back in here and multiply this fraction, and this fraction. So what we end up with, and I'll show you the big step this time, is 5 times 4x over x plus 7 times 4x over 4 equals negative 9 times 4x over x. And what happens is things can cancel out since you are multiplying everything on the top. Then stuff that's on the top and on the bottom at the same time go away. So this x right here goes away from this x. And this 4 goes away with this 4. And this x goes away with this x. And so what we're left with then is 5 times 4 plus 7x equals negative 36. And this is definitely a problem that now is a lot easier to solve. So go ahead and finish it out. And then subtract 20 from both sides. And remember, if you're going to combine two negative numbers together, you're actually adding them. So our final answer here is going to be negative 8. And real quick, just check it and make sure that when you put negative 8 into the denominator, you get a true statement. And in this case, you do. Okay, so here's a little word problem then. We've got an alloy formed by mixing two or more materials. Sterling silver is an alloy. That should be alloy. So let's clean that up real quick. Should be alloy. Composed of 92.5% silver and 7.5% copper by weight. Jewelry silver is composed of 80% silver and 20% copper by weight. So how much pure silver should you mix with 15 ounces of jewelry silver to make sterling silver? Alright, so the question here is we're trying to figure out exactly how much to mix of what to get sterling silver. So the percent of the copper is in the mixture. Let's talk about that first. And so we're going to talk about the percent of copper is equal to the weight of the copper in the mix. And we're going to compare that with the total weight of the mixture. Okay, and so when we go to solve this out, then we're just looking at how much is copper by weight, and so if we're looking at that sterling silver alloy, okay, then there's 7.5% copper by weight in there. So in other words, we're going to have 7.5 per 100 parts. Okay, that's your 7.5% right there. And it's equal to this fraction over here, which is the weight of the copper in the mix. Okay, the weight of the copper in the mix. And so in order to get that, okay, so what we want to do then is we want to look at the ratio, the percent of copper in the mixture compared to the total weight of the mixture, and then whatever gets added in is going to be my silver. So that's where the 7.5 over 100 comes from. And then on the bottom, I'm looking at 15 ounces of jewelry silver. So how much pure silver should we mix with 15 ounces of jewelry silver? So that's the X part that we need. And then on the top, we are still going to keep our copper together. So on the bottom is the total weight. On the top is the copper. And so that's going to be 0.2 for my 20%, which is highlighted up there. And we're talking about 15 ounces of that guy. Okay? And so what you're going to end up with then is this fraction right here, and we're going to cross multiply, which means that I need 100 on this side, and I need 15 plus x on the left. And use your parentheses so that you don't make a mistake, and you're going to have 7.5 times 15 plus x, and that's going to be equal to 0.2 times 5 times 100. And when we do this, do your math now, use your calculator if you need or whatever, but you're going to end up then with 112.5 plus 7.5x, and that's going to be equal to 300. Subtract your 112.5. Now we're just in solve for x mode. So 7.5x is equal to 187.5. Divide both sides by 7.5. And your new answer then is going to give you that missing value of x. So x is equal to 25. And since x is equal to 25, this is how many ounces of silver that needs to be added to get the right alloy. Okay, so on these guys, we've got a couple more examples here, and again, I'm going to show you the algebraic way and a calculator way so that you can see both the ways to solve these. But basically what we're going to do, we'll start on this left-hand guy. We want to get a common denominator. We want to clear out that fraction, and the easiest way to do that is to multiply the entire thing by the least common multiple, or least common denominator. And in this case, it's going to be x times x minus 5. So each piece of our function gets multiplied by that. So we're going to multiply both pieces times the first guy, both pieces times the second guy, and both pieces times the third guy. And this is exactly what we did a minute ago, so I'll write it out long ways one more time, and I won't on the next one. But I'm going to have 1 times x minus 5 minus 8 over x minus 5 times x minus 5 equals 3 times x minus 5 over x. And so these guys can go away. If you've got it on the top and on the bottom and it's a grouping, it can go away. It gets reduced out, divided out. It's gone. And so my entire fraction disappears and I'm left with x times x minus 5 minus 8x equals 3 times x minus 5. And so this is x squared minus 5x minus 8x equals 3x minus 15. And we're going to have a quadratic. Get everything to the left, and we'll either factor or use the quadratic formula. So let me clean up the left-hand side real quick. And then we're just going to move these two guys over. We're going to subtract 3x and add 15. Subtract 3x and add 15. And that's going to equal 0. So the thing to ask yourself is, what times what makes 15 and adds to 16? And this guy's going to factor to x minus 1 times x minus 15. And that's equal to 0. And so x minus 1 equals 0. X minus 15 equals 0. And so x is equal to 1 and 15. So we've got two answers down here. Okay, we've got two answers. Well, when you're looking at that, you just need to check and make sure if both of those guys work in the original function. So if we let x equal 1, you know, does 1 minus 5, does that work? You know, and so let's see here. So if I've got 1 minus 5, will that give me the answer that I'm looking for? And can I put 1 in here? Does this part work in our denominator? And the answer is yes, it does. It works, no problem at all. Okay. Then we're going to check what if x is 15. Okay. And so when you put 15 in here, 15 minus 5, that works, and 15, that works. So when we check our denominators with the values that we've got for x down here, and it does everything that we need it to do without being undefined, then we've got a good answer. So on this first guy, x equals 1 and x equals 15 are the answers that we're looking for. On the right-hand side, go ahead and factor x squared minus 9 to be x plus 3 and x minus 3. And then when you find that when you multiply by the common denominator, you're multiplying the whole equation by x plus 3 times x minus 3. And if you've noticed, we have a pattern of stuff that divides out. So when I multiply all of this to each piece, you'll notice that on that first guy, the x minus 3's divide out. This x minus 3 right here divides out with the x minus 3 that I'm multiplying by. So I end up with 6 times x plus 3. You'll notice on the second guy that I've got an x plus 3 and an x minus 3. They divide out both. So that just leaves me 8x squared. And on that last guy, I've got an x plus 3, and it takes out the x plus 3, so I've got minus 4x times x minus 3. Now, clean up all your parentheses, get all the like terms together on one side, 0 on the other. And this should be a 4x right here. And when I start simplifying this down, I'm going to go ahead and move over that 6x. I'm going to go ahead and subtract 18. So what you end up with is 0 equals 8x squared minus 4x squared. Okay. 12 minus 6. And then minus 18. And so on this guy then, you can actually divide a 2 out of everything. And what I mean by that is 2 factors out. I have 2 that comes out, and then what's left is 2x squared plus 3x minus 9. And if I divide both sides by 2, guess what goes away? 0 divided by 2 is still 0. So I've cleaned my problem up just a little bit. And now I just need to factor this. And there's all kinds of different ways that you can factor this guy. And so I'm going to go with 2x and x because I have to have a 2 involved. And then I'm going to subtract my numbers to get 3. So I just have to think about what times what is 9 that would work out and help me subtract to get 3. So I'm looking at this, and 2 times 3 is 6. Minus 3 is 3. So I like this guy. I need a plus 3, so I'm going to go with plus 6 here, minus 3 here, and that equals 0. So now I've got 2x minus 3 equaling 0, and x plus 3 equals 0. So that's going to give me then x equals negative 3 for one solution, and x equals 3 halves for the other. And even though we get these solutions, we still have to check in our original problem to make sure that they will give us a good denominator. In other words, a denominator where we won't have an undefined spot. So come back up here and just check 3 halves. 3 halves minus 3, that works. 3 halves plus 3, that works. Okay, no problem. But then go in and check your negative 3 and see if it works. And if it doesn't, we can't use it. So when I check my negative 3, I get negative 3 minus 3. That's okay. But right here, I get negative 3 plus 3. That isn't. That guy right there is equal to 0. And I cannot have 0 in the denominator. So the only answer I can accept is my x equals 3 halves. You've got to check this thing. And again, if you'll graph this and look at the intersection, there's only one point of intersection on this graph.